Hello all, this is Pratibha, Assistant Professor, Department of EEE, Nanda Engineering College. In this video, we are going to learn how to compile and dump a program into ARM LPC 2148 controller. In this video, we are going to learn how to compile a program using a compiler named IAR Workbench. So first open IAR Workbench. So the screen displays the IAR interface. So the first step is for compiling any program, we have to create a project. So click project and then create new project. The tool chain default ARM will be selected. So click OK. Now we have to save our project in a folder. Now we are going to compile a simple arithmetic program. So I'm naming the folder as ARM ARITH and then click save. Now the ARM project has been created and it is displayed in the leftmost corner. Now after creating the project, we have to create a file. So for that, click File, New, and then click File. So a new file window will be opened here. So in this space, we have to type our program. So we are going to now compile a simple arithmetic operation. Already I have typed the program in a notepad. So I'm going to copy. I'm going to copy the program and paste the program in the new file space. So once the program has been typed, we have to save the file. For that, click File and then click Save. ARM. I am giving the name as ARM arith1 dot extension is .s. So the file name is ARM arith1 and the extension we have to use is .s and then click Save. Now the file have been saved in the file name ARM arith1.s. Once the file have been saved, the next step is click project and then add file. We are going to add this file to the project we have already created. Add file. So the file I have created now is ARM arith1. So click ARM arith1 and then open. So we can see that in our project ARM arith, our new file has been added. Once the file have been added, the next step is click options. In this first general options, click device. The device is NXP LPC 2148. Next, we have to enable the core. Next step is output converter. Enable generate additional output. In this output format, click Intel extended and then enable output file override default. The next step is linker. Enable override default. So now we have to link. So now we have to create a link. For that, click this PC, C drive, program files x86, IAR system, embedded workbench, click ARM folder, examples, NXP, and then LPC 214X. Here, click Future Microblocks. Then click Timer Interrupt. Click Configuration. Click LPC 2148 slash ICF. So flash.icf, this is the file we have to link, click open. So now we have generate the link and then now click OK. The next step is we have to click rebuild all. So here again we have to save our file with a file name. So I am giving the same name arm arith1 and then click save. Now the window here displays that the number of errors is 0 and the total number of warnings is 0. So now the program has been run and it is found that there are no errors. If suppose we have any errors, the total number of errors will be displayed here, and according to the error, again we have to correct the program and again we have to go to the rebuild all option and run the program. So this is the step carried out for compiling an arithmetic program, arithmetic operation. Now here for viewing the result in the project, click download and debug. So in the rightmost corner, the program along with the registers we have used will be displayed. Now we have to click view and then register. So now what we are going to do is we are going to debug the program step by step and view our result in the register. For addition, we have used the inputs as R1 and R0 and the result is stored in R8. For that debugging step, click step into. So now R0 value assigned is 5 and again click step into. R1 value is now A. Now the program is in addition. So R1 and R0 will be added and the result will be stored in R8. So the next step, click step into. In the rightmost side, we can view that R8 value is now F. So 5 plus A, answer is F. That is A equivalent value in decimal is 10. So adding that 10, 10 plus 5 is 15. Again, it is converted to hex and the answer is F. And this value is now stored in R8. Now let us check the next process, arithmetic process, subtraction. So as we look into the program for subtraction, the result is stored in R9 and the input variables are again R1 and R0. The values assigned in the program are 5 and A. So now I am going to click step into. So the subtracted result will be stored in R9. So the R9 value is now 5. That is A value equivalent is 10. So 10 minus 5 will be 5. So that is now stored in the R9 register. In this way, we have to check the register value step by clicking the step into option. And the next is the multiplication process. So for multiplication, we are using R10 register as the output. So now 5 into A, that is 5 into 10, that will be 50. And that 50 converted to hexa value, we get 32. So this 32 is now stored in the R10 register. And next operation we have performed is 32-bit multiplication. So since we are using 8-bit and 8-bit, the 16-bit value will be shown in the output. So now I'm clicking the step into. So R11 value will also again be 32. So now, after addition, subtraction, and multiplication, the values are finally stored in the registers we have given in the program. So this is the steps carried out to compile a program and check the answer in the registers. So in order to change the values, we can simply change our values in the program itself. For example, now I am changing R0 value as 4 and R1 value as B. Now, now again save the program and then we have to again rebuild the project. So rebuild, I am going to click rebuild all. So this will terminate the current debug session. Click OK. Now our values are R0 and R1. R0 and now the values R0 and R1 are 4 and B. The program has been compiled and there it is found that the errors are 0. Now again we are going to download and debug the program. For that, first we are going to click stepping 2. So for that, first we are going to click stepping 2 option. So we can see that R0 value is loaded as 4. Next, clicking step into R1 value is B. And the final added value is again F. That is 4 equivalent B value is 11. So 4 plus 11 it is 15. Again the value is found to be F in addition. Next in subtraction, the subtracted answer is 7 because 11 minus 4, the answer is 7. Next, multiplied answer we get as 2C. So in this way, we can change the values and find the added, subtracted and multiplied results by giving the step into action. So by carrying out the sequence of steps we have discussed in the video, we can compile a simple arithmetic operation using IAR workbench. Thank you for watching this video.